Hey there, it's me, it's Al, the person that has no more people watching his videos. I was thinking to try and come up with anything that might be, something interesting, C++ wise. And I've been writing a lot of code, and a lot of it useful, but I don't think it would be very interesting to go over. One thing, for instance, I just added, because I'd like to use this in the future, is the tree control. See, these things, nothing to it. It's totally trivial. I mean, it's one of my TS control things. One of the things I thought might be of interest, and I'm not really sure, but I could try it. Well, let me prepare it. Hang on. Well, I managed to set this thing up. I don't know how interesting this is going to be. But what I've set up is something called a race condition. It has to do with critical sections and the use of critical sections causing what they call a deadlock. I could try and draw a picture maybe of how the standard deadlock scenario. If there's only one critical section in the world, then it's okay. You won't get any deadlocks. But if there's more than one, then the potential exists for a deadlock to occur. Now, suppose I represent a critical section as a square, a colored square. Like that, except a square, a rectangle. We can call that critical section 1, and we'll give them different colors. Let's suppose there are 2 in the world. I'll try to make them the same size. So here's critical section 1. Text, size, what is the size? So that's that one, and this one is that, and you can imagine a critical section as being a type of object, although it's not really. The critical section uses a type of object. I guess you can call it an object then. And I would think of it as a kind of like a token, a token that you can have or not have. And a critical section token is one that you can share between threads. You can share between threads. One thread can own a critical section at a time only. So if your thread owns the critical section, no others can own it. They have to wait for you to give it back. So let's imagine a thread as what kind of thread look like? A great big circle, black circle. Let this be thread 1. Okay, and we'll imagine that there's at least 2 threads in the world, and here's another one. Okay, now how shall I represent code? A picture of some sort of code, maybe. I might do another image editor. I can manage that. This is good for fast things. I wouldn't want to use PaintShop Pro. Well, let me pause this until it loads up. Okay, I got a pretty good image here for code, I think. A bit too big. What I'm going to do. Darn it. When you resize it, it loses its... Hang on a sec. If I can get it back. It's just a bit too big. Alright. Too big. Here's a piece of code, let's say. Here's another one. And another one. One more. And almost fits. Oops. I just want it a little bit separated. Okay, it doesn't have to be perfect. Now what I'm going to do is draw a colored square around one piece of code to indicate which token is required in order to use that code. Okay, now this might be, it could be the same actual code here as here. It might be a different code guarded by the same critical section, or it could be the same code exactly. So let's say this is a red one, and I don't know, this is a red one, and these other ones, green ones. Alright. Now how does a deadlock occur? Let's suppose thread 1 is running and enters one of these critical sections. How do I indicate that? I'm going to indicate its current location with a star. What color? A green star. No, not green. We're using green. A blue star. Let's suppose that thread 1 is currently inside here. Okay. Okay, that's fine. Now, it's possible that there could be a context switch and thread 2 might get entered. Now, thread 2 certainly is not allowed to enter this area of code yet, right? Until thread 1 relinquishes this one. But it could certainly be in here. So let's suppose thread 2 is currently in here. Alright. And now let's suppose that it turns out that thread 1, it needs to get into here, this green one, right? It certainly can't, not allowed to yet. But the next line of code, perhaps, would be in here, and make that black. So it's moving. That black arrow indicates where it's trying to move to. So thread 1 is waiting now for the green token, which is currently owned by thread 2. Now let's suppose, similarly, thread 2, its next line of code is in this section, right? Well, it can't enter that section because thread 1 is currently owns that section. You see? And this here now we have is what we have is a deadlock. Make that bigger. Make it bigger. Yeah, I can choose bigger font. This situation, as it's being shown here, is a deadlock. Because there's no possibility of either thread advancing. Because this thread, if its next line of code is to go into this green area, right, and it can't get there, then it can't release the red box that would allow this one to get to its next line of code. See what I'm saying? So, because of the fact that there are two critical sections in the world, or more, the possibility of a deadlock exists. And I've concocted a deadlock scenario, and the tricky bit was to try to make it something that was intermittent, so that it doesn't happen all the time. Usually, the kinds of things that cause deadlocks, which are often called race conditions, the name race condition, its meaning is very similar to what it sounds like. A potential deadlock is there, but only if something happens in just the right timing. For instance, if thread 2 had managed to get in and out, right, it would have before thread 1 got in, then everything would have been fine. Even if thread 2 managed to get from here and into here, there's no problem because thread 1 starts here. I'm assuming it enters in here. So thread 1 would have to wait to get in, but we wouldn't get a block. Okay, so I'm going to demonstrate the race condition. The deadlock that I concocted with my UA program, and it happens this way. And then I'm going to show you how difficult it is. Oh, I changed the icon. How difficult it can be to diagnose these problems. Now, it occurs in this scenario. I click Browse here, Now suppose I click that browse and I select a program that doesn't have an icon. This is how I've set it up, the condition. When I click on this, a little dialog box will come out saying there's no icon. Okay, no problem. And then I might try another one. Okay. Find something with some icons. And whatever, everything's working fine. Now, this is the one. I know where one is anyway. I don't have to click that cancel. You see that thing disappear on its own and everything's fine. But occasionally, and I wanted to make it at least reproducible. So I should be able to get into a deadlock if I wait long enough here at this before hitting this OK button. I should get one. Oh, yeah, it's deadlocked now. The program is hung. It's in a deadlock scenario. Now the question is, why? Now there are a whole bunch of threads here, okay? Now you can see that one is certainly waiting on a critical section. And now all these other ones actually have to do with that dialog. And they're all, it turns out, this is their address, they're all on the same line. That line here, sysenter, will become familiar to you if you do a lot of multi-threaded programming. And this is, it's, I think, the line either enter critical section or just wait for a single object, that sort of thing. Now I'm pretty sure that this DX indicates a timeout period. So this particular one is going to time out and it'll die. And a lot, in fact, almost all of them will die. Some of them, see, this one's about to die. So I'll let it run a bit longer. So get rid of as many as possible. Okay, now we're down to not too many. Now you'll notice that this changed. Okay, so this thread's actually still doing something. At the moment, it's doing something with the icon list box. Okay, and this one is doing something to do with malloc. And this one here is still on this lock, critical section lock. And I think we'll lose about 2 or 3 more. Those other threads come up because of the common dialog. The browse dialog starts out with about 1 million threads. Now that's this one, which happens to be here. Okay, so it's received a WM timer message, and it's waiting on this critical section. Okay, now since it's waiting and it hasn't gone in immediately, and it's been like sitting like that for a long time, obviously that M here is locked already by another thread. And I believe it's locked by this one. which is doing some kind of allocation. Actually, it's doing a free. Okay. Yeah, this is the message box we were watching, right? And I waited a long time, and I had just clicked the OK button. Now, clicking the OK button has caused this thing to try and free some memory. See? And the memory being freed is the temporary TS string, I believe anyway, that was created for the message. No icons found in such and so file, right? You can still see the file name. Okay, you can, and the fact that you can still see that file name means that that memory hasn't been freed yet. Okay, now it's strange, but and I don't really understand why this is, but at this line, it looks like it's calling malloc, but the size is 0, so I figure malloc 0 is the same as free, just like realloc, the way realloc works. However, if this is to be taken literally, okay, then what's this line doing? Allocating some more memory, right? Not freeing. This thing is trying to allocate memory, and it's weird too, because the size, I don't know, this changes. I've seen it at different numbers. I don't know what NH flag block in this block use is wrong. That can't be right. That's like int min. No, it's not. Looks like an address. Could be an address. It is an address. And it has an address. At that address there's an address. FD297AC. FD297. I think that address is it's in NTDLL. No, it's one digit off. 0F is not. Is this an address? F? Oh no, it's pointing here. 28, right? FD, oh yeah, FD297AC. That's not an address at all. Oh no, 1A. Let's go back there again. FD297AC. Let's make sure again. Yeah, no, that's not an address. So what is that? I don't know. File name is garbage. Line, again, line looks like an address. Okay. File name. I know where this address is. That's in NTDLL. 77 A's and B's is NTDLL. See? That's 8 digits. So that's an address in NTDLL. These numbers, God knows, I probably don't. It's probably garbage. For some reason, this function, it appears, but the debugger is in a confused state, because really where this thing is, surprise, surprise, is on the same line as everybody else, waiting for something, right? And the waiting occurred the intermediary step from here to that NH mount. Oh yeah, it looks like a direct. This would have been a direct call, and in fact, it is, right? Size 0. Block use. That's not right. This number can only be. Let's see the right. Yeah, it's messed up. It's messed up. You can't trust anything here because it doesn't have the registers. It does have EBP though, so it should be able to figure that out. 1, 5, 1, and then 4 zeros. Okay, that's memory. Where is it? It's at the very beginning, it looks like, of something. Okay, well, we can probably we can figure out where that is. I dumped the addresses of things. Not the, oh, am I dumping, oh, I'm not dumping the heaps, no, unfortunately. That you see how difficult it is to debug these things. First off, this call, whatever happened, this is either not reading it right, or something else happened, and it only appears as though this called this, but maybe it called this, which called something, which then called it, recursively again or something. Because this is all wrong. Registers, we don't have EVP, so we can't see. If this is useless. See, all these things are based on EVP, and we don't have EVP, so we can't tell what their values were at the time. But we can have okay, so that explains that thing. That explains why the debugger is showing us like garbage here. None of this has any meaning. So, okay, this is correct then. That called through user. Okay, now MSCTF, which is theme and then common control. What's CTF DLL? Probably common control something. Something to do with themes, more common control stuff. And I bet you anything, my guess is that this sequence is trying to print out an assertion failure dialog. Because of these all this common control stuff, and the fact that all those threads timed out, I believe that one of these things is actually trying to print out an assertion dialog box, and therefore it's trying to allocate some memory. Possibly, anyway. Now, in order to allocate memory, go back to our threads. One of them is actually doing it now. We can have a look. Even though it's freeing, you can still see the malloc code. Now remember, this is already in here, this thread. Okay, we'll have to just go back again. Alright. Here's a lock. Where's the unlock? Try. No, if there was an exception, it would have been unlocked here, so it's still locked. This here, the heat lock is still locked. Okay. Now this thing's trying to call free, right? Now, this here may indicate a context switch, but it's still in this thread. The other thread, this one, okay, I wanted to point something out. Okay, it's waiting for something. It's waiting for this particular lock. The thing I wanted to point out actually, I think is in here. The reason why I think that it's trying to print in the searching dialog, where is that? One of these. Not that. Where is it? At one point, there's a call to a function, which presumably would be just to display a message box. And the very next line says int3. Yeah, but I can only find it. Here. Oh, yeah, okay, yeah. Here. See? All of these. All these other ones. However they got here, are trying to print out an assertion box message, because assertion box messages, right? The line immediately following the message display is in int3, right? And that brings you into the debugger. But they're not getting there because they can't get past this, whatever this is. Okay. And that's called through pointer, and we don't know what that pointer is because we've lost the registers, right? And we could probably have those registers retained somehow using some of the debug register features, but I don't know how to do that. Now the question is, where's this scenario? Well, certainly this one, this thread does not own the M critical section. In fact, we know that that's owned by this thread. This one owns that currently, right? Because it was acquired here, and then the message box came up, right? And we clicked OK, but the OK can't continue until it can free this memory. And in order to free that memory, it's got to acquire the malloc critical section, and one of these threads owns that. And in order for it to continue, it needs to acquire this thing. Now that may possibly be this thread. It seems like the only likely one, right? Whoops. Where's our... Here. Okay. This is on this line. And that's going into NTDLL, which is just waiting. We can go backwards a little bit here. It may be you see these dialog procs are re-entrant, right? It might be in this same function at a different point on the stack, where it might be trying to allocate something. Now, I'm trying to find something like that. On LV selected, okay, here, alright, here's a TS string. Now that's already been filled in though. Oh no, we're on do modal. Do modal, which puts us here. Okay. That put us into the thing that brought up the icon dialog, which was another do modal. Whoops, darn it. Which was load new icon file, which brought up this percentage indicator, which started another do modal, which brought us in here, and I don't know, I don't see that it's in the middle of malloc. But now let me think now. If this thing auto release, that doesn't do any allocating. This doesn't do any allocating. It's very complicated. It's confusing. But, you know, there are these other threads, right? This thing, that's okay, that's that one. How about this? What's this thread doing? It's in the middle of this call. Well, this one should still be running. What if I do F8? Oh, can't step. This thing seems to keep changing. When I run it for a while. See, it's changed. Now it's on a wait. Okay, now why is it on a wait? Don't know. Oh, sorry. It's trying to print out an assertion box. So everybody's trying to print out an assertion box. And we've got these two are the only two that aren't. The assertion boxes are not getting printed out. They're timing out eventually. And those threads are dying. And somehow or other, this one owns the malloc critical section, and it is not able to complete that malloc until it acquires this critical section. Why? Why is that? It's got to do with this sequence. User, user, user. Now, if only we had the registers. What does it look like this does? Push 7, and 7 is a specific number. Like a string or something. Now that's why these things are very difficult to debug. Because I actually, generated this deadlock, and I don't understand where it's how it's in a deadlock state. I don't see anything in malloc. But that's the other thing, right? It may be that there are those two critical sections around. But there are other critical sections that get acquired and released that could also get themselves tangled up in a scenario like this and cause this thing to have to somehow I'd like to know which thread this actually, what is this thread again? Is this the one that just printed the message box? Yeah. This one's definitely trying to get into free. And it can't get into free. And it has to be that because these two never, well actually there's two others that never disappear. That other WM timer one might just be an artifact. Although, the longer I let that timer go, the longer the interval, the less likely this deadlock scenario occurs, I found. See, now we've only got this many left. But these two hang around too. This is a weight 0, right? Now, why would it be a weight 0 if it's trying to print an assert dialog? Oh, right. We don't have the registers. It could be in infinity, right? Oh no, we have all these registers. Okay. It's in you know where it is. It's in NTDLL. EDI for some reason it has been set up, not sort. Okay, no, that's garbage. What's EFL? Flags. Okay. I don't know what else we can see. There's nothing there. Okay. Well, maybe there were some symbol names. No. But we can get a better idea. ESP, move into ESP. This looks like, and it is, I see. This here is, looks like a cache, like a structured exception cache, right? You've got pointers to pointers, this being dereferenced twice, right? Load effective address of what's on the stack into stack pointer, do it again, right? And then put that in DX for some reason. No, what's the first thing that's at FS18? I forget. Is it a? It's not a signal or any. This is structured exception handling code, I believe. That's this thread. Okay, so it's crashing, right? It's in a try except and it's crashing, and it can't even get through the crash code. This one, probably the same thing. Well, trying to print out a cert dialog. It's not exactly the same. One structured exception and one just a plain old assert failing. So I guess it's not very interesting, is it? The point is, it's very, very difficult to diagnose these things, and I'll show you how to avoid this one anyway. And there's a hint here in this comment that a message box can persist, and the reason that is a bad thing or a dangerous thing in this scenario is because we are currently holding a critical section. You don't hold critical sections for any duration of any length of time. That's not what they're meant for, right? Critical means something that has to happen by only one thread at one time very quickly. And I had the fix code already in place. I didn't have to wait for the bug to come up. I knew that there would be a bug if I didn't do it. And I copied it up here to hide it. What you got to do, if you want to do a long, lengthy thing, and you happen to own a critical section, is you've got to release it. What I did here, it's already been done, is while I have the critical section, this is guarded data, and this is guarded data, and this is guarded data. And I copy the guarded data into local variables, a local variable, a name, unlock the critical section, run my dialog, and now I gotta lock it again because this thing is going to do an unlock. So just for balance, I have to relock it and then return. And now it'll never happen. And I can put that timer back to what it originally was. Not 3 seconds, but just 100 milliseconds. At 100 milliseconds, it deadlocks immediately. You want to see? I can show you. It's not that interesting. It just deadlocks. Now it's perfectly fine, and it can't possibly deadlock. Yes, it can't possibly deadlock because the allocation, that string that goes into the message box, is freed before this thing is relocked, right? So there's no danger of getting getting the two critical sections, this one and the one to do with malloc, tied up and in a knot and end up with a deadlock. This cannot deadlock. That memory will be freed before I call this lock, and everything's again totally safe because I'm not in. Nothing's going to call malloc in this thread while the thing is locked. Okay, so now it'll work fine. It doesn't matter how long I let that dialog stay up. I can let it stay up there forever. This is now loading those trillions of threads. Okay. In fact, that box has disappeared on its own underneath, so it's fine now. I don't have any more problems. Deadlocks are very difficult to diagnose, and for the reasons, one of the reasons is what you just saw. Often the symptom shows up the symptom shows up in a place that's completely unrelated to where the bug is, right? And that's what makes it so hard to get rid of. Now, why have I done this? Debugging. I don't remember where it was. Program. Windows Media Components. Yeah, that's it. Alright, so I don't know. I may upload this, I don't know. Is it interesting? I don't know. See you.